Alright, here we're going to look at the evens you had to do. This is page 131 in your book, and you guys 2 through 14 even. Okay, so we're going to kind of work through these. Alright, so let's start out with number 2. I'll just work it down here. Number 2, we have 5 to the 3x is equal to 25. Now, right now, what we need to do is get the same base. Okay, well, we can rewrite 25 as 5 squared. So we'll have 5 to the 3x is equal to 5 squared. Now, put the x minus 4 in parentheses so that we can remember to distribute through. So let's distribute the 2 through. Now, once we have the same bases, we can just put the exponents equal to each other. So we put 3x is equal to, again, we're distributing this, it's 2x minus 8. Okay, now we want to get our x's together, so I'm going to subtract 2x from both sides. So we end up with x is equal to negative 8. So that would be our answer to number 2. Alright, for number 4, we have 2 to the 3x is equal to 4 to the x minus 1. Okay, we've got to get the same powers. Same base. So we'll change this from 4 to 2x. So it'd be 2 to the 3x is equal to 2 squared, which is replacing the 4, and then x minus 1. Okay, now we have the same base, so we just put the exponents equal to each other. So we have 3x is equal to 2 times this. I'm going to distribute this. So I'm going to get 2x minus 2. Combine like terms. So I end up with x is equal to negative 2. Alright, question 8. We end up with 25x minus 1 4x. Alright, get the same base. 5 squared gives us that. And so I'm going to write that as 5 squared x minus 1. Now, 5 to the third power will replace the 125. Alright, so what we end up with here, I'm going to distribute the 2, so I get 2x minus 2 is equal to 3 times 4 is 12x. Okay, we're going to get our x's together. So we end up with negative 2. Don't forget to keep that negative with that, or subtraction sign, however you want to look at it, but this got to stay together. Then I got 12x minus 2, so I get 10x. Okay, and then what we're going to do here is divide both sides by 10. So we get negative 1/5. I just reduced is equal to x. Alright, I'm going to go ahead and we'll look at the inequalities. The only difference is you got to be careful when you multiply or divide across the inequality with a negative sign. So let's go ahead and look here. These already have the same base. So I'm just going to bring that down as 3x plus 1 is less than or equal to, I'm working on number 10, x minus 9. Okay, I'm going to get my x's together. It doesn't really matter which way you move, but typically we like our x's on the left side, especially when we're doing inequalities if we were graphing them. But anyway, we end up with 3x minus x gives us 2x plus 1 is less than or equal to negative 9. Subtract 1. Okay, and so we end up with 2x is less than or equal to negative 10. And then we're going to divide both sides by 2. So we end up with x is less than or equal to negative 5. Alright, here we have 5 to the x minus 4 power is less than or equal to 25x minus 6. Alright, so we got to get the same base. So I can leave that alone, and I'm going to rewrite 25 as 5 squared. Now I'm going to distribute this 2, but now that since we have the same base, I can just put the exponents equal to each other. So I have x minus 4 is less than or equal to 2x minus 12. Okay, now what I'm going to do here is I'm going to move the 2x over. So I end up with negative x. Bring down the minus 4 is less than or equal to negative 12. Remember, this has got to stay together. Okay, now I'm going to add 4. Okay, so now I have negative x is less than or equal to negative 8. Now be careful here. We have a negative variable. We don't like that. So we're going to divide both sides by negative 1. Now when I divide by negative 1, I'm moving it across the inequality. I'm dividing. Anytime I divide or multiply by negative across the inequality, I have to reverse it. So it's going to be x is greater than or equal to 8. Alright, let's go ahead and look at the last one that I assigned to you. Alright, with this we had number 14. We have 8 to the x minus 1 is less than or equal to 32. Okay, to the 3x minus 2. Now this one may not seem as common, but yes, 8 goes in there, but you have to multiply it times 4. It's not a power. So what we're going to do here is write this in terms of 2's. 2 cubed gives me 8. Okay, then 2 to the 4 gives me 16 times 2 gives me 32. So 2 to the 5th power gives me 32. Okay, so here I'm going to distribute the 3 through. So I get 3x minus 3 is less than or equal to 15x minus 10. Okay, now let's go ahead and move the x over. Okay, so I end up with negative 12x. Bring down the minus 3. It's less than or equal to negative 10. Okay, I'm going to add 3 to both sides, move the 3 over. So now I have negative 12x is less than or equal to different sign, subtract. Okay, take the sign of the one with the larger absolute value. So I end up with negative 7. Then I'm going to divide both sides by negative 12. Okay, now this is where you have to be careful. I'm dividing by negative across the inequality, so I have to reverse it. So for this one, I'm going to end up with x is greater than or equal to 7/12. Now it's because I end up with double negatives here, that's why it's positive, and I switched the inequality because I divided by this negative. Alright, so since you're watching this, and I'm going to give you a little bit of an extra here as far as you'll see a problem like this on your quiz. Alright, now let's look at it. If a population of 100 grows by 6%, so it's a growth problem. So what we need to do is I'm going to convert this to a decimal. So I'm going to use this as 0.06. Okay, how large will the population be in 20 years? So we're going to write a function. So our function, okay, we started out with 100. Okay, then it's going to be 1 plus the 0.06. Okay, to the t power. So the function that I'm looking for here is 100 and then 1.06 t. So we can figure out based off of this what the population is in any year. Now for specifically this one asks for 20, so what we'll do is just plug in 20 for t. Okay, now with rounding this ends up being 321. After 20 years, that's the population. I'm going to go ahead and do a depreciation problem, a type problem you'll see too, and then we'll be done with this. Alright, here we have a depreciation problem, which is the decay. Alright, and this is again a type of problem you would see. Okay, we're going to write a function for it. So this is our starting value. Now we're decreasing, so we'll end up subtracting 1 minus whatever. So here it's 25%, so we're going to use 0.25. So we'll have 1 minus 0.25 to the t power. Now, with this, we end up with 22,500, then 0.75 to the t power would be our function. It would model the depreciation here. See what the car is worth after 5 years. Alright, so after 5 years, that car we just had to have, we paid $22,000 for, is worth $5,339.36. If you can do these types of problems and the ones earlier, you'll do well in the quiz. Good luck.